Hi everyone, welcome to this lecture series on Oracle Cloud Infrastructure Foundations. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this particular module, we are going to look at the various compute services offered by Oracle Cloud Infrastructure. Specifically, we are going to look into bare metal offerings, virtual machine offerings. We'll look at various options around scaling, whether it's horizontal scaling or vertical scaling. We'll look at Oracle Container Engine, which is a managed Kubernetes service, and then we'll look at Oracle functions. So first, let's look at the continuum of offerings we have in compute. And this is similar if you have gone through the storage module or the database module or even the networking module for that matter, you would see that we offer a wide range of services to meet your workload and application requirements. So as you can see here, we have bare metal as a service. We'll talk about what that is. We have dedicated virtual hosts, we have virtual machines, we have container engine and functions. And all these are in a way, this is a continuum of compute, and these are all different flavors of compute offerings. So start with bare metal. In this case, you basically get a physical server without any virtualization, and we'll talk more about what that is. But as you can see here, you have to manage the virtualization layer. You have to manage all the things which are on top of that, operating systems, your runtimes, etc. In case of a dedicated virtual host, we do give you a machine which is dedicated to you, but you can run VMs on top of that. It has virtualization. So this thing is now offered as a service. In case of virtual machines, well, the virtual machine is a guest on a host server with hypervisor-based virtualization. This should be very familiar. This is the public cloud multi-tenant model, and here you are managing things like operating systems. You are patching them, you are upgrading them, your runtimes, your code, etc. But you're not managing the virtualization layer because as a cloud provider, we actually take care of that. In case of container engine, you are managing your code, and then of course you are managing your app container. An app container, if you think about that, that is a container runtime which executes containers and manages container images on a node. The most widely known app container or container runtime is Docker, but there are other options available as well. And then finally, you have Oracle functions where you just write the code. You write the code in different languages and you don't worry about any of the underlying infrastructure, and we take care of all that. And you write your own code, you deploy your code, you can call it directly, trigger it in response to any kind of event, and then you only build for the resources consumed during the execution. So this is really consumption based pricing. And all this, all of these, basically we have a pay as you go model, but Oracle functions really takes it to the next level where you only pay for the resources consumed during the execution of your code. So hopefully it gives you a good idea of the different offerings we have as part of the Oracle Cloud Infrastructure Compute Services. Now, why do we have these many offerings? Well, it depends on your application requirements. You might actually just want to write code and run your application like that, or you might actually want to run it, manage the whole thing in a bare metal machine. Now we talked about bare metal. You basically get a physical server without any virtualization. Now, one thing to keep in mind, we also have this, you would read with Oracle, this thing called off-box virtualization. So you might say, oh, well, bare metal has no virtualization. What is this off-box virtualization? What we do in off-box is we offload network and storage to a separate hardware card in the server. People also call it as custom silicon. So lot of these storage and network operations are done by this card, custom silicon, which sits outside the server. So that's why off box, but the server itself, there is no virtualization. That's bare metal. Virtual machine, guest on a host server with hypervisor based virtualization. In case of Oracle Cloud Infrastructure, we take the bare metal machine and then we slap an hypervisor on top of that, and then you can run your VMs. This is typically the multi-tenant model. And then there is a third model which is called dedicated VM host. Now, in this case, we do the same thing as a VM based offering, but the offering is single tenant, meaning you get access to the whole box. So you ensure that the whole box has VMs which are only owned by you, and you don't have a green and a red VM, meaning VMs from two different customers on the same box. Why would you do that? Well, this gives you the highest level of sort of security, right? And you can manage the whole thing yourself. It's sort of it's best of both worlds. You get a whole dedicated machine, but then your VMs are only yours, right? It's a single tenant VM model. One thing to keep in mind, because all of them use the same underlying bare metal machine, so our APIs are very consistent. These offerings are a first-class citizen of the bare metal cloud service. So the bare metal service runs underneath, and then you are running whether VMs or you're running dedicated virtual host. They call the same APIs. Well, what are the use cases for bare metal? The first use case is workloads that are intensive. So the first thing, yes, you would run databases on bare metal, but workloads that are not virtualized. Again, a lot of the databases were never virtualized, so you could run on bare metal. Workloads that require a specific hypervisor, right? You might actually have heard this term called bring your own hypervisor. So you could run your own hypervisor, and depending on your use case, use a specific hypervisor. And then workloads that require bring your own licensing, right? So if you're running SQL or you're running Exchange or something, you might actually want to bring those workloads and bring your own licensing. And in some cases, you actually require a bare metal machine in order for those licenses to work in compliance with the requirements. Well, a virtual machine. This is the simplest model which public clouds really made widely available. And before that, VMware, you have a hypervisor running on a machine. You want to use a virtual machine when you want to control all aspects of an environment. It gives you the maximum control. You want to deploy a legacy app, whether you might be running something in Windows or Linux. As I said before, public clouds, VMware really came in and virtualized had this offering on virtualization, which really led to better resource pooling. And that's why it became powerful and widely used, right? So you might still be running VMs and legacy apps in those, right? So if you're doing that and you want to use public cloud, well, your one option, which is the simplest, is to move them, package them, and move as a VM. You can also use VMs to move applications from on-prem, like I was talking about. So if you're migrating something, VMs actually make a lot of sense. VMs require work. That is one of the downside to a VM model. It gives you the maximum control, flexibility, etc. But you have to manage things, right? You have to patch the operating system. Same with us, same with any cloud provider. You have to manage your security configuration. You have to manage your network security, your firewalls. You have to take care of things like monitoring, constantly seeing if something is going on with the virtual machine. You have to take care of things like application configuration, because you're deploying your applications to the VM, so it's your responsibility to configure them properly. And then finally, you also have to manage things like scaling. So if you throw more traffic to your VM, more load, variable traffic, your VM has to scale accordingly, otherwise your application might not work optimally. So those are some of the use cases why you would use a virtual machine, and some of the things considerations to keep in mind when using VMs. Well, with that, let's look at some of the instance basics. And these basics apply to the bare metal, apply to the virtual machines, and apply to the dedicated virtual host. It doesn't matter. So that's why we have instance here. I'm not calling virtual machine or a bare metal, right? It's the same across all. Why? Well, we talked about all these offerings in internally uses bare metal. That's where it's built as layers, right? So they have the same APIs. Well, like any cloud, we have different sizes, right? You have CPU, RAM, your bandwidth. You have different sizes for your instances, whether it's virtual machines, whether it's bare metal. We support both Intel and AMD. And AMD processors are typically 50% cheaper, around 50% cheaper than Intel. So that's the price performance thing. If you're looking for, you could go with AMD, could go with Intel, which is the common model in the cloud. We have instances specific to GPU and high performance computing HPC, and things like RDMA and interconnect, and lots of detail which comes with those instance types. And then the thing to keep in mind is, though we talk about compute as sort of in isolation, compute in fact depends a lot on networking and storage, other services, right? So if you think about it, you have your instance. The instance actually boots using something called a boot volume. So think about this as where your operating system disks are kept. Instance also has data, right? Let's say you are running a database or you're running VMware or something, right? Your data actually doesn't live on the local instance, though you could do that, direct attach storage. Typically you would have remote storage, and this storage is actually stored on a service using a service called block volume. Your data, think about them as data disks. Boot volume and block volume are the same offering, meaning the boot volume is a type of a block volume. So boot volume specific use cases keeping the operating system disks from where the instance boots, but it's kind of a it's a kind of block volume, right? And then finally you have virtual cloud network where you get lots of networking capabilities. Now that's a very simplistic picture. Typically what happens is, to make it a little bit more complex, you have regions. We talked about this in the physical OCI architecture. Within the region you have availability domains, might have one, might have three, and then you create a virtual cloud network, which is a logical construct. It's a software-defined networking you in OCI. Now you spin up an instance. What happens is instance has a physical NIC here. So this is your network interface card. This is physical. We virtualize this and we call this virtual NIC, and this virtual NIC gets placed in the instance subnet. So typically sometimes you would see that the instance is shown here. In reality the instance doesn't live within this logical construct, only the virtual NIC lives within that. Why do we do that? Well, in virtual NIC we would assign things like your private IP, we would assign things like your public IP, we could secure your instance using a firewall here, or in the on the NIC itself we could put a firewall here, right? So those are some of the advanced networking capabilities you get by on the NIC itself, right? And the NIC runs in a specific subnet. Now, as we talked about, the compute instance also uses the block volume service, right? And there are two kinds of flavors of block volume that it leverages. One is called the boot disk, where your operating systems are kept, and then the other one is the data disks, which are also called as block volumes, and this is where your data resides. So this is sort of a more realistic picture of what an instance looks like in OCI, and similar in other clouds, right? So you have instance, it leverages your virtual cloud network. Basically, you keep a virtual NIC in a subnet. You could do a bunch of things here on security, IP addresses, and then the data lives on remote servers, and the instance boots from there. The boot disk and the data disk is all kept remote. Why do we do this? Well, if instance becomes unavailable, your data is still running, it's not lost, right? And we talked about virtual NIC. You get your IPs, you get your security lists, your network security groups. You could secure your instance, right? Well, so let's look at two kinds of scaling supported by Oracle Cloud Infrastructure. The first one is called vertical scaling, and vertical scaling basically means you can scale up and scale down. So you could go from a one core machine to a two core machine, or a four core, or a eight core, or so on and so forth, right? And you could go up or you could go down. Um, and New shapes have the same hardware architecture. In this case, I think most of the public cloud, there's a downtime which is required. So instance must be stopped before you can resize it. I believe there's a feature coming where it's automatic, but right now this is a consideration. You keep limitation you have to keep in mind when you change the shape. It's a very brief downtime which is required. Stop it and then you can resize it. Well, there is also something called auto scaling, which is literally horizontal scaling. So what you could do in auto scaling is you enable large scale deployment of VMs from a single gold image with automatic configuration. So let's say you have one instance running, but you want four copies of that instance. You could scale out. This operation is called scale out, and you get four instances. You started with one, now you have four. So you added one plus three. And you can also do the reverse, right? So if you have four instances running, you could from four and you reduce one and you go to three instances. This is called scale in. So scale out, you add more instances. Scale in, you remove instances. Why would you do that? Well, idea here is if one VM fails, your others will still keep working. So you get high availability. That's why you would use horizontal scaling. This is the predominant application architecture in the public cloud. Um, and again, the idea is you can match your traffic demand by adding or removing VMs automatically. And we do this in OCI based on matrix, whether it's CPU or memory. You could actually match the traffic demand by adding or removing VMs. And this is going back historically. This is one of the key reasons why cloud became so powerful. Because in on-prem world to do this was super complex. In cloud, it's actually much easier, and you can automate the whole process. And then the great thing is there is no extra cost for using autoscaling. So how does it work? And again, this is a foundations course, so we are not going into a lot of details, but I just want to at least give you some idea. It's actually really straightforward. You have an instance running. What you do is create a configuration, and configuration is nothing but, as you guess it, operating system image, your metadata, storage disks, all that stuff, right? It's basically learns about what your instance looks like, right? You're creating this thing called a gold image here, right? Then what you do is you take this configuration and you create what is called an instance pool. And as you can see here, instead of one instance, now we have two, and you could do many more, right? And the idea is you could put these instances in different availability domains, and then now you can manage all of them together. You could stop them, you could start them, you could terminate them. So now, and you can update them. So now, instead of managing one VM at a time, you're managing at scale. You could manage hundreds of VMs, right? In one sort of as together as one unit. So that's really gives you the power. And then what you do is you define your scaling rules. You could say that if CPU or memory goes beyond 70%, add two instances, and if they go below 70%, remove two instances. And then what happens here is you have an initial size. You could add plus two more instances, or you could, if the the matrix you define say that if the particular threshold is met, you actually can remove two instances, right? And this is basically what auto scaling is. You could automate the whole thing, and this is really gives you the power to match your traffic load and scale your application sort of seamlessly. All right, so we talked about lots of things on virtual machines, on bare metal, and we looked at the basics of instances, and then we looked at the how you would do scaling, whether it's vertical scaling or whether it's horizontal scaling. Now let's look at containers. In the next 2-3 slides, we talk about containers and the Oracle Container Engine offering, and then we'll finally conclude the module talking about Oracle functions. So, well, if you think about traditionally, what happened is there was the concept of virtual machines. We talked about a VM is a guest on a host server with hypervisor-based virtualization, right? So you have hardware, you actually have a thin layer. It's what is called a virtual machine manager, VMM, your hypervisor, and then on top of that, you have VMs. Now, if you see in this picture, VMs include operating system, right? So each VM has an operating system, the necessary binary libraries, etc., etc. Now, VMs took shape because they led to better resource pooling. Before VMs were there, you had this whole thing as a monolithic. You could only run one application. With VMs coming in, you could slice this hardware into various virtual machines, led to the better resource pooling. But there were some downsides to VMs as well. The first being, in case of a VM, you were repeating the operating system everywhere, right? And so these became bulky. You're packaging operating systems in all the VMs. So if you, let's say in the previous example, we talked about auto scaling. If you have 10 VMs, basically you're packaging the operating systems 10 times, right? So it's a bulky model, it becomes hard to manage, etc., etc. So now we have this concept of containers where we raise the abstraction one more level, and now we virtualize the operating system. So if you see these two pictures, let me just remove these here. If you see this picture now, we are raising the abstraction one more level, and we are virtualizing the operating system. So operating system is here, and now we have containers which are running on top of that. So containers include the app and all of its dependency, but as you guess it, they share the kernel or the operating system with other containers. Now in this way, containers are not tied to the guest operating system like the VMs here, right? They're not tied to any specific infrastructure. They can run on-prem, they can run in a public cloud, they can run in any public cloud. So the question then becomes is how do you deploy these containers? Because literally you're not going to just run one container. You're going to run massive number of containers, right? Like you do with virtual machines. Now there are various ways to do it, right? You could manually SSH into machines, run containers. Well, Docker is the most popular container runtime, and there are other container runtimes as well. So there's one option to do that, right? You could do scripting or config management, but typically what became really powerful and popular in the last 2 3 years are these orchestration systems. So what are these orchestration systems? Well, the one which is the most popular is this thing called Kubernetes, and sometimes you would also hear people writing it as K8s, and there's a story on why that name came and why they named it like that. But it's an open source orchestration system for automating deployment, scaling, and management of containerized applications and containers, right? So the thing to keep in mind, this is all beyond foundations, and there is a course on Kubernetes we have, and Oracle Container Engine, etc., etc. But just to give you an overview, the way Kubernetes works is Kubernetes doesn't run containers directly. What it does instead, it wraps containers into a higher level structure called a pod. You can see these two pods running here. Think of pod as the smallest deployable unit that is created and managed by Kubernetes. What is really pod? What does it represent? It represents a group of one or more containers you can see here, right? And these containers, like we talked about, you could use Docker as the container runtime. You could use something else. They have shared storage. We're not showing here. This gets a little bit more complex. They also share network namespace as a unique cluster IP address, and they also have things like information about how to run each container, image version, specific ports, etc., etc., etc. Right? Lots of detail. Not getting into this foundations course. Now, each pod is tied to the node where it is scheduled. Right? So you see these two nodes here, and these nodes are actual your instances. So these can be bare metal, these can be virtual machines, whichever model you want to use. Uh, the pod is tied to the node, so you can see here where it lives, where it is scheduled and remains there until termination. Or you could have a restart policy, or you delete it, right? So this is basically how it works at very high level. And there's lots of details on Kubernetes, and lots of training content available. Now Oracle Container Engine is a fully managed, scalable, and highly available service based on Kubernetes, as you guess, that you can use to deploy your container applications in OCI. We also have this service called Container Registry, Oracle Cloud Infrastructure Registry. It's a managed Docker container registry service, and it can be used to pull images for Kubernetes deployment. These containers are based on images, and OCIR services running here. You could actually store your images in that, and you could pull those images for your Kubernetes deployments. Well, the final thing we want to talk about is functions. Functions is a serverless offering, right? This is the smallest, I would say, really the smallest unit of compute, or where you write code which generally does one simple thing and does that, and then it dies, right? That's basically what functions do. And this is again, this whole category of serverless offerings. That's basically what functions is. With Oracle functions, you can write code in Java, Python, Node, Go, and Ruby. And you could, in fact, for other use cases, you could actually bring your own Docker file. And then you deploy your code, like we talked about earlier. You call it directly, or you could trigger it in response to events. And then you get billed only for the resources consumed during the execution. So this is really sort of takes the pricing to the next level, consumption based pricing rather than pay as you go pricing. And you can see here how it works. You push the container to a registry. It actually uses containers beneath the layers. Then you configure the function trigger, and the code runs only when triggered, and you only pay for the execution time. One thing to keep in mind is Oracle Function is based on FN Project, and FN Project is an open source container native serverless platform that can run anywhere, any cloud or on premises. So that's one unique differentiation functions has compared to some other serverless offerings out there. Well, folks, that's it. In this particular module, we looked at bare metal machines, physical servers without virtualization. We looked at VMs, the different scaling options available with VMs, whether it's vertical scaling, horizontal scaling. We very briefly looked at what Kubernetes is. Oracle Container Engine is a managed Kubernetes offering in the cloud. And then we looked at functions based on the FN project, serverless offering, and it's sort of the smallest unit of compute available in Oracle Cloud Infrastructure. Well, thank you for your time. I hope you found this information useful.